We're going to go through and summarize the first couple sections in Chapter 6, which is on the normal curve, and then we're going to get into the new section 6.3 and 6.4, how to use the normal curve, and how to standardize numbers, and how to look up numbers on the standard normal curve, which is what you have as a table. In 6.1, basically, you were talking about looking at a histogram, and on the histogram, you saw that as you increase the number of data points, you can have a data structure that is somewhat symmetrical, and as you increase the number, this histogram will eventually turn into something more like this, which would be considered the normal curve. And when you had the histogram, if it was a relative frequency histogram, you had the probability here, and then you had the R value here. And on the normal curve, what you have is the probability on the inside, and you have your mu and your standard deviations down below. So what you're going to see on the 6.1 is that you have your standard deviations to the right and to the left, and you had something called an empirical rule. And the empirical rule says that there is a certain percent of chance that your data will be within one standard deviation. And so this was the 68%, the 95%, and out to 3 would be your 99.7% rule. And so that means that the data under the curve, the probability under the curve, if it's 3 standard deviations away from the mean, there's a 99.7% chance that it will exist. Or an item chosen at random will have a 99.7% chance of falling within 3 means of your mu. And then we use these probabilities, these percentages, to help us find out parts of the normal curve. And I often had to half them in order to find out a certain area under that curve. And so at this point, we're going to be moving to 6.2, which says I can't do that for all of my data points. I can't find my probability. Sometimes I'm going to need numbers that are different than the specific standard deviations, like 1, 2, 3. So I'm going to standardize this by using a formula that says your z is equal to the x minus your mu, your deviation, how far you away from the mean, or divided by the standard deviation. So that z-score is in deviations, in standard deviations away from 0. One standard deviation is going to be a z is equal to 1. And so then I now can convert from x to z. Now what we're going to do is we're going to say, I want to use my z-scores and look them up in a table and be able to work with it. So to do that, in your notes on 6.3, you're going to see that it has information about this normal curve. And I'm going to go through and explain a couple things. First of all, in 6.3, you're going to see that 0 is going to be where your mean is, and then 1 represents 1 standard deviation away. So these are actually z numbers now. And it also says that the area under the curve represents 100% or 1. And now we can use a table by looking at these numbers down below. All right. Then what's going to happen is you are going to have certain situations on how to use the table. Now, the table is going to represent, let's say your z-score is 0.5, and you want to know what the probability is that it's going to be 0.5 away from the mean. What you're really doing is you're looking at this area right here. Now, when you use the table for the normal curve, that table is going to always go to 0. It's going to go to the mean and stop at the mean. So whenever you look up a number on the table, you have to think it's the number to 0 that it's representing. That's going to be the probability that x, or z now, is going to be between 0.5 and 0. That's what that red represents. So when you have, for example, a table like this, you're going to see it's 0 to your z-score. All right. I'm going to go through both notes in the packet first, and then we'll go to on the screen just to keep it consistent. 6.4 notes is the same exact stuff. It's just putting it in story problems. So how do you go ahead and find probabilities on your table? At the beginning, we have to convert your x scores to z scores, and then once we have the z scores, we can look at the table. The most important part of the notes is down at the bottom, which is part number 4, and it says hints for successful solution of these problems. And it does a good job explaining the certain steps that you're looking at. So 6.4, number 4, says clearly list all the values given in the problem with appropriate labels such as mu, little sigma, x, or z. Second, determine what is the unknown. What are you solving for? Third, write down the appropriate formula. The appropriate formula we know is the x minus mu divided by the standard deviation. Lastly, draw a standard normal curve for each of these problems. So we're going to be looking at that. All right. To look at the standard normal curve, we're going to be looking at this table and trying to understand what it means. And so, first of all, I have to understand that on the left side, that represents the z-score to the nearest tenth. Now, notice a couple things. It's just going from 0 to 3.6 and stops at 3.6 because that's pretty much 49.99%. It does not have any negative numbers. Why? Because as you see on this normal curve, the right side and the left side, there's symmetry. So whatever you have for the z values, the negative z values are the same exact thing when you're looking at probabilities. So if you had a 1.1 probability, if z is 1.1, you look up the probability for it, you'll get a probability. That probability will be the same exact probability between 0 and negative 1.1. So if it's positive or negative, you look up that number on the left side. It's kind of like an absolute value, and you'll still find the same probability from that number to 0. And on the top gives the hundredths place. So you know if it was 0.63, it's going to be right here. So you have 0.60, 0.61, 0.62, 0.63. Now, with a table, you can go from z value to the probability, which is on the inside, or you can go from the probability to the z value. So you have to look up the probability and then go back to the z value. So there's two ways of doing it. Let's go to the problems, the different situations that you can get. Now the situations you have in your notes, which are actually in two places. You have it on the handout that I gave you, which is this, and you also have it in your notes packet, which is right here. Now, you do not need to memorize these situations. It should just make sense. In other words, go for understanding, do not go for memorization. If you go for memorization, then these things can get mixed up pretty easily. So when I do this, I'm looking at the problem. What is the probability that your z is going to be between 0 and 1.34? That means go to 1.34 and look up the probability, because it's going to tell me what it is between 0 and 1.34. So I go 1.34, which is going to be right here. And so that means that this is just going to be 0.4099%. And that's all you're doing. That is the probability. You don't have to do anything else on this one, because it's going from 0 to the number. Let's go to the next situation. Next situation says, okay, I have a negative z and I'm going to a positive z. What's the probability of those two numbers, between those two numbers? The answer to that is I'm going to divide this into two parts, and I'm going to find the probability here, and I'm going to find the probability here. Because again, the probability is always from 0 to the specific number. So when I do this, the probability of positive 0.63, because it's symmetric, is going to be right here, 0.2357. And then I want to add the probability of 1.1. So I'm going to go here, 0.3643. And I'm not going to add these numbers. The main focus, you would add these numbers, but the main focus is what we're doing in this situation. You add the two. It makes sense. You break it down into parts. Let's go to the next one. What's the probability that I'm going from 0.04 to 3? In other words, I have a section off of 0 now. So how do you get this? And the whole thing is it's part plus part equals whole, or whole minus part gives you the other part. So the whole is from the z, the big Z, to 0, and then the part that you can find is from 0 to z sub 1. And if you subtract those two, you're going to get the remaining part. And that's, if you can remember that in this section, it becomes easy. So how do I do this? I find the probability from 0 to z sub 2, so that's going to be probability at 3 is going to be 0.4987 minus. And then I'm going to subtract off the space here, probability. So that's going to be at 0.04, which means it's going to be right here, 0.160, way up here. And when I subtract those two, the whole probability minus that part, it's going to give me the other part. No need to memorize. And so then you'd get your probability. Next one. This shows that I want to go from my z-score to a positive infinity. So I'm going to remember that from 0 to the right side, that whole thing is 0.5. So it's going to be 0.5 minus this whole, H-O-L-E. So it's like the whole, W-H-O-L-E, minus the whole, H-O-L-E. You know what I'm saying? So we're looking at the probability from 0 to 1.4, which is going to be right here, 0.4192. And when I take 0.5 and take that whole out of there, you're left with the shaded. Take the whole probability, the whole area, the 0.5, subtract off the part, you're left with the second part. Lastly, you have something where you're taking the right side and you have an additional left side. Again, we're breaking it down right at the middle. The right side is just 0.50. The left side I just need to look up. So it's going to be 0.5 plus 1, let's see, Z is 1.72. That's going to be right there, 0.4573. So I'm taking my 0.5, I'm adding this probability, it's this plus this will give me the whole thing. Should make sense, it's going to be over 0.5. No need to memorize what you actually have to do. You can take all of those handouts with the pictures and what to do in each case and forget about it, because if you understand what you're doing in these situations, you don't need to apply those. All right, let's go ahead and solve two problems that are more story problems. And this will get into 6.4. These problems you don't have in front of you, so you're just going to have to follow on here, but it kind of will show two practical problems on where this whole situation is going from. It's talking about police calls, and then we're talking about a warranty for a product. So the police calls, basically when you read this, it's saying that you're looking at when the dispatcher gets the calls to when the cops show up. And so what's the mean and what is the standard deviation of that? So they're going to have a long list of dispatcher calls to when they actually show up, and they're going to find the mean of it, and they're going to find the standard deviation of it. And so they did that, and they got your 8.4 and your 1.7. The questions are three. What's the probability that when the dispatcher is called, the police are going to show up between 5 and 10 minutes? What about less than 5? What about greater than 5? Greater than 10? And so we're going to go ahead and do that. And so the first thing that I want to do is I want to say, all right, what do I know? I know my mu is 8.4. I know my standard deviation is 1.7. I know that my x's are this. Now what I want to do is actually convert my x's so I'm dealing with z's. Once I get z's, I can deal with the table. So the first thing, again, we're going to use this equation. And so for 5, the z-score at 5, I can do z sub 5, is going to be 5 minus 8.4 divided by your little sigma, which is 1.7. And so therefore, that will give you -2. Then you have the other one. So it's going to be z of 10. And that's going to be 10 minus 8.4 divided by 1.7. And that should be equal to 0.941. These are your z's that you're going to want to keep in track of and put on your normal curve when you draw it. Okay, so I have three scenarios. A, B, and C. So when you have those scenarios, you're basically looking at drawing these curves. And again, you always want to draw these curves so you have a nice visual. Between 5 and 10. Well, I'm looking at between -2 and positive 0.941. That's going to be -2 and positive 0.941. That means this is my probability that I want to find. Secondly, less than 5. That means I want to be less than -2, which means that is my probability that I want to find. Again, these are my z-scores. Lastly, more than 10 means more than 0.941, which means that's what I want to find. Okay, now I have a visual of the probabilities I'm trying to find. Now I want to actually go ahead and do that. So when I look at this, again, I want to break it down into two parts. I want the probability, or from Z, I can show you what that, so probability that Z is between -2 and 0, plus the probability that Z is between 0 and 0.941. Adding this plus that. This one, what do I need to do? This is 0.5 minus the probability of this. So it's going to be 0.5 minus the probability of Z being between 0 and -2. Lastly, that's going to be, again, 0.5 minus the probability that Z is between 0 and 0.941. The whole side minus this part is going to give me what remains. Now, when you do this and look it up on a table, you're going to find that this probability is 0.4772 plus 0.3264 is equal to 0.8036, which means, and we want to focus on the meaning of the answer, it means 80.36% is the chance that when a police call is made, that an officer will show up at the door in a matter of 5 to 10 minutes. Next, 0.5. Looking that one up, we already have that number, minus 0.4772, which will give you 0.0228, means 2.28% chance of the cop showing up at 2.28. That the cop will show up less than 5 minutes. The last one is going to be the chance that the policeman shows up after 10 minutes. So that means that it's going to be 0.5 minus 0.3264, 0.1736, 17.36% chance that the policeman will show up after 10 minutes. That's one type of situation. A lot of different problems involving that same scenario. Let's go to the next one. This next one's a little bit more challenging. It's using the same thing, but it's just, you got to remember a couple little tricks as you go through. So, first of all, it says you have a computer system and you have a life expectancy for the mean, which is 30 months, and you also have a standard deviation of 4 months. I'm going to write that down. My mu is equal to 30. My standard deviation is equal to 4. The question here is, how long? What is your X? How long can the guarantee period be for if management does not want to pay more than 7% of the people that it sells the software to? How long does the warranty have, how many months does the warranty have to be good for them not to spend all this money on paying these people out? So they want to know. So what's really happening is it's giving me my percent. Therefore, when I look at this graph, the percent, it says no more than 7%, which means that it's 7% or less that it's paying out. That probability is 7%. Now, I need to know what my z-score is, because I want to use the table in reverse to get my z-score. This is where you have to know the trick, and students will forget. The trick is, on the table, know that you're always going from 0 to the z. Therefore, I don't care about that 0.07. I care about the 0.43, because that's what gets you to 50%. This is the number I want to look up on the table, because that will give me my z. So I want to take 0.5 minus 0.07 to give me 0.43. And now what I want to do is look up 0.43 on my table. 0.43 on the inside of my table, and select the number that's closest to 0.43. Now, if I look at 0.43 and I see that it's exactly in the middle between two numbers, then just go 5 more than the 0.0 number 5. You're going to go to the thousandths place. But if it's not exactly in the middle, just choose the closest number. So when I'm looking at this, this is 8 off, and this is going to be 6 off, so there's my answer. This one right here, 0.4306, which means it's going to be 1.48. 1.48. All right. 1.48 means my z is a negative 1.48. You can do everything right and forget that negative sign, and now all of a sudden the problem's going to be wrong. Why is it going to be wrong? Because this is not my answer. I want to know the number of months, not the z-score. That means I have to transfer it to a z-score. How do I do that? I use the equation. So it's negative 1.48 is equal to your x, which is going to be what you're trying to find, minus your mu, divided by your standard deviation. That's the main equation. And when you do that, you're going to see that your x is going to equal 24.08. That's why this is important that that's negative. If it's positive, you're going to get the wrong answer. So I know 24 months should be what this is going to relate to, 24 months. If you think about the x-scores, this is 30, this would be 24. So now it's a little bit of a technical question. Is it 24 or is it 25? The answer is in the directions. If management does not want to refund the purchase price on more than 7%, that means they want to refund 7% or less time. That means that it has to be 24 months, which is going to be the warranty period for this product for the management not to pay more than 7%. That's a lot of information today, and I had to do so because of the AP test. So tomorrow we'll go through questions again. If you have them, and just keep track of your letters. Write stuff down, just don't put answers.